Well, hey, it's so good to see you, even though I can't really see you. But let's go ahead and work through some exponents. Um, let's just go ahead and get rolling here. Exponential form. Okay, I'm actually going to start with that because that's going to help me kind of have a conversation with you. So an exponential form, like 6 to the 7th power is written in exponential form. The base of that number is the big number. It's the number that I'm going to be doing my multiplying by, and my exponent is the little number at top, okay? And 6 to the 7th, if I want to write this, so this is an exponential form, 6 to the 7th power, and if I wanted this in expanded form, it would look like this. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. That would be an expanded form. So 6 to the 7th power looks like that. And that's what it means. It's 6. It's 7 sixes, but it's being multiplied together. So, all right, I just grabbed a calculator so I could find 6 to the 7th power. 6 to the 7th power is 279,936, which is in standard notation. So standard notation, expanded notation, exponential notation. All right, so that would mean like 5 to the first is itself. Anything to the first power is itself. 5 to the second power is 5 times 5, which is 25. 5 to the third power is 5 times 5 times 5, which is 125. 5 to the fourth power is 5 times 5 times 5 times 5, which is 625. And 5 to the fifth power is 5 5s being multiplied together, which is all the way up to 3,125. Now you can see, and we call this exponential because it grows really, really fast because of the multiplying. So I can read this as like this particular number right here. Actually, I'm going to go like to this number right here. So this can be read as 6 to the 7th power, like 5 to the 4th power. But if it has an exponent of 2, it has a different answer. You would call it squared. And if it has a 3, you would call it cubed. If it has a 4, you wouldn't call it quad, but if it has a 2, you can call it squared, 3 cubed, and then from then on you can just read it to the power of. Okay, let's work on these a few more. Ooh, just like we saw, a bunch of 6s. So this is a common base, which is 6, and then there's 1, 2, 3, 4 of them. That is 6 to the 4th power. Number 3, I'm going to go ahead and I'm going to look at my coefficients, which is 3 and negative 2, and I'm going to bring those together first. So 3 times negative 2 is negative 6. And I'm going to look for, okay, I've got a p here, 1 here, and 1 here. So I have p to the third. And then I've got a q and a q, so it is q to the second. And that's what it would be simplified. On number 4, I'm going to grab my coefficients of 2 and 5. 2 times 5 is 10. I've got 2 a's, so it's a to the second. I've got a b, so it's just b, and then 2 c's, which is c to the second. All right, once you press pause and you guys do 2, 5, and 6. All right, check your answers. Got my coefficients, combine my bases together, and because we're multiplying, I can add my exponents together. All right, so let's find the area of the rectangle because the formula for area is length times width. My length is 3x times my width, which is x. This is the same thing as saying 3 times x, and when I have the same base, I can add those exponents because there's 2 of them, so it's 3x to the second is what the area is of this rectangle. Why don't you go ahead and press pause and try number 2. I got 10a to the second when I multiply those together. And if we were talking perimeter on something like this, this guy right here, actually let's talk about the first one. Okay? So if we were talking about perimeter of this, we have an x. So the perimeter is if the length is x, and then there's another x, and then the other side we have a 3x, and then I've got another x. And this is perimeter, so I'm adding all the pieces together. For this kind of thing, now this is an adding problem, so my question would be how many x's do I have? I have 3 here, 3 more here, 1 here, and 1 here. So that would be 8 x's. So remember, this is different than exponential change. Like exponents happen when you're multiplying. You're combining x's here when you're adding. So try to keep track of the difference of these as we see them. Okay, be careful when you're evaluating functions because the parentheses do influence it. Like for instance, right here, this cubed is being cubed to both areas with the parentheses. This is actually saying 2 to the third and y to the third. So that is 2 times 2, which is 4, times another 2, which is 8. So that ends up being 8 y to the third. Now this 3 right here, that exponent, that actually is only attached to the y, so this is already simplified. 2y to the third is 2y to the third, already simplified. Why don't you go ahead and try this one right here. All right, the top one, because of the parentheses, it was 3 to the fourth, x to the fourth, and y to the fourth. And 3 to the fourth is 81. And the bottom one, the 4, is only attached to the y, so that's already simplified. All right, we're going to do some evaluating, which means like substitution. And I'm going to watch my parentheses on this one. So this is x to the third, and I'm going to plug in the -5. Now I'm going to put my parentheses in there because this is telling me -5 times -5 times -5. So a negative times a negative times a negative will be negative, so I know my answer is negative. 5 times 5 is 25, times another 5 is 125. So that's what number 1 would be. Number 2, I have 4 times x to the third, and x is -2 to the third. Okay, so I'm going to do -2 times -2 times -2, which is -8 times 4. So I have 4 times -8, and I'm going to get -32. Now this guy right here, I got to pay attention to some stuff. So this is saying I've got a 4 to the third power, because this is going to be distributed over, and then I have my x. This is times x, which is -2, and that's also to the third power. Notice I distributed my 3 to both terms. Now I'm going to do some more simplifying here. It's 4 to the third power is 64 times -2 to the third power is -2 times -2 times -2, which is -8. So I'm going to take 64 times -8, and I get a -512 as my answer. All right, why don't you press pause and you try number 4. All right, I substituted in. I kind of wish there was a negative in there. Kept it more interesting for you. And yeah, that would have been nice. A summary of order of operations. First, simplify the expression within the grouping symbols. So if you have parentheses, like for instance, if there's an exponent out here, but there's a 4 times -2, then deal with the 4 times the negative first. Do that inside. Simplify the powers. That would mean like distributing the powers. That's kind of what it's looking for. Simplify the products and quotients from left to right. Okay, so that would be once you have 4, that's not a good example. Once you've distributed your powers, and then you have like a to the 4th times 3 to the 5th times 2 to the 4th. If you have something like that, then you can start combining pieces of those things together, and then do the sums and difference. So it's very PEMDAS or GEMDAS, very order of operations. Just the exponents are now a big part of this, and it influences the whole thing. All right, so this is where we're seeing how the negative and the exponents are really involved here. So -3 to the 4th power. What this is saying is -3 to the 4th power. So it's asking me, what is 3 to the 4th power, which is 81, and then the negative gets attached on. So you can see how the negative, the exponent of 4, is not attached to the negative. It's just attached to the base of 3. It's kind of like saying -1 times 3 to the 4th. That's really what this is saying. But on number 2, this is saying a different thing. This is actually saying 4 to the -3rd power. So this is saying -3 times -3 times -3 times -3. And that actually ends up being 81, but a negative times a negative times a negative times a negative will be positive. So you can see how this is a negative answer and this is a positive answer. I'm still getting the 81, but they're on different sides of the number line. So keep track of your parentheses. Order of operations tells me here that I need to add the inside together first. So 1 plus 5 is 6. and then I can square that. So keep an eye on that thing. Parentheses are influenced here. For number 4, this is telling me I need to do my exponent first. So 25 plus 1, and I get 26. So keep track of those parentheses. I'm going to have you do that whole bottom row, 5 through 8, press pause, and let's see how you do. All right, how'd it go? Notice no parentheses here, so my answer will be negative. With parentheses, so it might be positive, it might be negative, just depending on how many negatives I'm needing. In this case, it's positive. Number 7 and 8, I did my order of operations. Example 5, okay, we got to do some evaluating here. Okay, let's put all this together. So 2 times my A is 3 plus my B is going to be negative 2, and all of this is cubed. So this is an order of operations situation here. So I end up with a 6 plus negative 2. So that's like taking away 2. So that's 4. And it looks like it is, my answer is 4 to the 3rd power, which is 64. When I simplify this whole thing. Whoa. Oh yeah, this will be fun. Go ahead and press pause and you give it a try first. Order of operations. All right, I substituted everything in, being careful of my positives and negatives. I did order of operations. I ended up with negative 3. Take a look at your answer and my answer, and check to see if we're doing the right process. All right, that's it for exponents. I'm going to go home and shove a bunch of cotton balls in my nose and see if it smells like a cloud.